Hello everyone, and today is the 7th of December. We are ready to approach the 7th challenge of the Advent of Code. And yeah, as always, as all 6 previous days, we are going to use AI in order to solve these problems, and then try to figure out what was the solution and how details of the solutions they provide to understand better, probably to learn something new. And yeah, we are reading the problem fully, and then we are using cursor in order to solve using AI. And let's get started.
The historians take you to a familiar rope bridge over a river in the middle of a jungle. The chief isn't on this side of the bridge, though. Maybe he's on the other side. When you go to cross the bridge, you notice a group of engineers trying to repair it. Apparently, it breaks pretty frequently. You won't be able to cross until it's fixed. You ask how long it'll take. The engineers tell you that it only needs final calibrations. But some young elephants were playing nearby and stole all the operators from their calibration equations. They could finish the calibrations if only someone could determine which test values could possibly be produced by placing any combination of operators into their calibration equations, your puzzle input.
Yeah, those elephants, always do such things. So we have a broken bridge, we need to fix it. And again, we have some problems, some equations that we need to test some values. For example, we have some numbers, and
each line represents a single equation. The test value appears before the colon on each line. It is your job to determine whether the remaining numbers can be combined with operators to produce the test value. Operators are always evaluated left to right, not according to precedence rules. Furthermore, numbers in the equations cannot be rearranged. Glancing into the jungle, you can see elephants holding 2 different types of operators, add, plus, and multiply.
As I understand now, it's just basically you need to build a calculator that will try to figure out which operators do we need to use, plus or multiply between those numbers in order to get this number, this test value. Should be really simple problem, and yeah, if there's nothing added, then GPT-4o Mini should nail it. Let's see what's next.
Only 3 of the above equations can be made true by inserting operators. 190, 10, 19 has only one position that accepts an operator. Between 10 and 19, choosing plus would give 29, but choosing would give the test value. 10, 19 equals 190. 3267, 81, 40, 27 has 2 positions for operators. Of the 4 possible configurations of the operators, 2 cause the right side to match the test value. 81 plus 40, 27, and 81, 40 plus 27, both equal 3267 when evaluated left to right. 292, 11, 6, 16, 20 can be solved in exactly one way. 11 plus 6, 16 plus 20. The engineers just need the total calibration result, which is the sum of the test values from just the equations that could possibly be true. In the above example, the sum of the test values for the 3 equations listed above is 3749. Determine which equations could possibly be true. What is their total calibration result?
Okay, so really interestingly, with this equation, we could have 2 possible outcomes, like 2 possible matching operators that will give us the same result. Why did they do that? Not sure, but probably some context of the second part. but we just need to get a sum of the test values, the testing numbers, which appear on the left, by just trying to figure out which of the equations could exist. Yeah, pretty simple task. Firstly, let's get our puzzle input, place it into the day 7. Then we go back and copy the task, and we provided like solution which said day 7. We provide a readme into our composer, just for the context of what the tasks are. We provide a task description, and we have a solution file attached. So it also would be in the context of the composer, so of the AI anyway. Yeah, we can toggle GPT-4o Mini and let's solve. Why did it try to solve the second part of the task while we just didn't provide any explanation for the second part? What did it do anyway? Implement logic to evaluate outcome. All right. So, as previously in the previous video, as I remember, GPT-4o Mini tried to have us implement the solution, but actually we are asking it to implement. I will try once again. It will revert code back. I hope this time GPT-4o Mini will give us a solution, not a placeholder for that. Yeah, seems like it is. It's not correct, or is it? Function has been implemented to evaluate each equation by checking all combinations of the operators plus and star. But I'm not sure I see star. I see plus and minus. Oh, product. So we have some function product, but where did it? Why? So let's see. Product. Undefined name product. Okay. I won't give GPT-4o Mini no more attempts to solve this. It failed twice to write a code there that will work. Let's try Claude 3.5 Haiku. I'm pretty sure it should correctly figure out the solution. Okay, we're reading input. We evaluate equation. We have operator plus and multiplication. We need to solve equation. How did we do that? Test value, num string, test value. Okay, we separate the test value which appear on the left, and then we get everything as integers into the numbers variable. Then if only one number, check direct match. Okay, try all possible operator combinations. Correct. By the way, we have again some function product. Oh, I see. It's from itsatools. So probably just GPT-4o Mini was trying to use the product from itsatools, but it just failed to import it. Okay, let's just copy the code here. Again, usually Composer will apply the code it wrote to the file we attached, but here probably my prompt problem. I have a system prompt that is asking it the AI to plan like we have a code analysis, a planning for the task, different approaches, consider pros and cons, and then code, and then explanation. What does the code do? But for some reason, either it's a composer problem, cursor, or just the system prompt should be slightly changed so that it will be able to apply to this file. But I just copied it and it should work fine. Let's again see. Try all possible combinations for ops in product. I'm not sure what product does actually. For ops in product, repeat, evaluate equation, list operations, evaluate equation, LLMs operators, result for I in and operator in enumerate, if operator plus, if else multiplication, and then we either add to the result or multiply the result. Then we return result, and if evaluate the equation equals to test value, what we need to find, we return true. So the part 1 should return sum of integers, which are the test values. Yeah, I'm mostly sure this would work fine. Let's activate our virtual environment. Let's go into DO7 and let's run solution file. Quite a number. Yeah, 1 gold star, perfect. So what we see here is that Claude Haiku 3.5 Haiku solved it correctly. Probably GPT-4o Mini would could solve this task as well, but it failed to import the product function, so I just didn't give it a chance. But never mind. The problem is easy. What's the part 2? Let's see.
The engineers seem concerned. The total calibration result you gave them is nowhere close to being within safety tolerances. Just then you spot your mistake. Some well-hidden elephants are holding a third type of operator. The concatenation operator combines the digits from its left and right inputs into a single number. For example, 12 was 345 would become 1, 2, 3, 4, 5. All operators are still evaluated left to right.
Okay, I see. So we have another operator, probably that we can use. Yeah, holding a third type of operator. So we can use another type of operator that we just can again use it as one of the types and just brute force the operators and check if the numbers are, if the formulas will apply and will get us the test result. Okay, let's see next.
Now, apart from the 3 equations that could be made true using only addition and multiplication, the above example has 3 more equations that can be made true by inserting operators.
Okay, so we have test value 156, then we have 15 and 6 that could be combined like into one number. Here we can this number could be made true using 6 multiplied by 8. Then what? Then we concatenate the value, probably multiply this, and I'm not sure of the order here. So if yes, 6 over 6 over 8, it's 47, 48. Is it? Yeah. Yeah, it's not like concatenate both parts. it's probably we should have what's here 48 48.6, so 486 multiplied by 15, probably it will give us this result. Okay, let's see.
Adding up all 6 test values, the 3 that could be made before using only plus, and plus the new 3 that can now be made by also using nice, produces the new total
Nice.
calibration result of 187. Using your new knowledge of elephant hiding spots, determine which equations could possibly be true. What is their total calibration result?
You just if you haven't known, this symbol is called nice. Just joking. Okay, so let's copy part 2. Sorry. Seems like a pretty straightforward problem again. I don't see any problems in just brute forcing this thing. So let's what should we do? Let's start a new composer, attach again readme file, and we have already attached our solution file. Task 2, and let's see firstly GPT-4o Mini. I would like to give it a chance. Just handling the concatenation as a separate operation. It doesn't seem to do anything with it. I'm still not sure what the product function gives us. What's the function of it? Could we just try every possible with a for loop? Iter-tools is iteration tools, so probably something with iteration. Let's just ask it. Hi Jarvis, what's the function product does? Product function is a part of iter-tools module. It's used to compute Cartesian product of input variables, which means generate all possible combinations of the input elements, allowing for repetition. Oh, just cycles them. Probably just cycles them. So we have two lists, A and B. Using product would yield 1A, 1B, 2A, 2B. Oh, it's like a and it repeat 2. What does it do? 1 1. Oh, if we provide just one list, that it will try to repeat it. What just repeat? What does this thing do? 1 1 1 2 2 1 2 2. Like it's how do you call it? Just forgot the name. Yeah, it's all possible, generating all possible combinations. In your code, product repeat length of numbers -1 generates all possible combinations of the operators plus 0 and concatenate for the number of operators needed based on the length of the numbers list. This allows to solve a equation function to test all possible ways to combine these numbers. Okay, I see now. So just for the sake of all possible combinations between the operators and the numbers. Didn't know about that. I like to learn something new again. Did it apply? But 2.0? Hasn't it applied? I don't see any changes. Evaluate equation. Yeah, here it is. So equation. Okay, just didn't fill the part 2 thing. Let's solve. What do we return again? The same thing. I would say. So equation. Yeah, it should be just the same thing. Let's see. Yeah, and part 1, we don't need to solve it yet. And it definitely took more time. Previous time it was instant answer, and currently you can see just stuck in just stuck. We can wait for some time. We could even, I think, calculate the progress if you'd like to. Yeah, we have an answer. I wonder if that's correct an answer. Yeah, 1 gold star, perfect. So, the task was pretty easy. I've heard that it's interesting that on the day 7 we got such easy tasks, because I remember the author of the Advent of Code was saying that on the weekends people do have more time. It's a Saturday today, so people have more time and they have more time to think. Then therefore, he's usually giving us harder problems on weekends. We'll see what we get tomorrow, but today the problems was straightforward, pretty straightforward. I would like to see not Claude 3.5 solution, but Claude Haiku, but Claude Sonnet. Haiku would solve it, definitely. Let's see what Sonnet gives us, and let's add something. Make this as optimized as possible for faster result. Because we did need to wait for some time. Let's see what does it say here. Potential approaches. Extend current product-based approach with concatenation. Simple to implement, maintains existing code structure. Yeah, that's what it did, the GPT-4o Mini. Const still generates all combinations, which is slow, yes. Use dynamic programming with memorization. What does it do? Avoids recalculating same sub-problems. Can be significantly faster. Cons which are more complex, high memory usage, I don't mind. Early termination optimization, chosen approach. It already chose before analyzing all of them. Okay. Stops as soon as valid condition is found. Didn't it do it before? Minimal memory usage, simple to understand and maintain, still needs to try combinations, but with better pruning. What are the changes? Evaluate expression while in line operators. So currently just using while loop for operators instead of product, probably. Convert current result, next number to strings, concatenate, then convert back. Integers plus string. So if concatenation, we concatenate. If plus, we just add. If multiply, we multiply. Solve equation. Minimum possible plus num, min possible multiplied by num. So early termination checks. If test value is smaller than the first value, we have concatenate operator, or test value is smaller than the sum product of all numbers, skip. Yeah. We'll see if it's faster. Check if concatenation of all numbers equal test value. Probably faster than just doing multiplications, but it's already doing it here. I'm not sure. Handle potential overflow. Okay, let's see. Not so fast as I thought. Yeah, probably it's not faster. And we'll see if we get the same result, by the way. I would say, let's give this problem, yeah, the same result as before. Let's do, you know what? Let's revert back and try 01. Check out. Let's try 01. I'd really like to have it a more optimized approach. So make this as optimized as possible for faster result. We give it what we already have. Just feel no. Write full code of the module. I think it will be enough. It started thinking, enhancing code, running left to right evaluation, aiming for cleaner integration. Okay, I like the quality of code. Better than it wrote before. So let's see what did it do. There are multiple functions. Can solve basic, can solve extended. Check if equation can be solved using only plus and multiply. Check if equation can be solved plus, multiply, and concatenation. So it just tries to solve basic, then it tries all combinations. Okay, I'm not sure if it's faster, but we will see. We get a first result. And here again takes some time for the part 2. Hello, warm place. It definitely is not faster. Probably even slower. Yep. Seems like it's a little slower. I don't see why do you need to check firstly the base, like the basic, and then concatenation. How would it go faster? Because we terminate anyway if we get a final result. By the way, the answer is different, and it's not correct. Sorry, OpenAI. The thing you released like 2 days ago is just giving me a wrong answer. It's 2 days ago, probably, or yesterday. I've tried 01 and it just didn't write code firstly, then it wrote invalid code 2 times, then only on the fourth attempt it solved, and the solution was good, by the way. But now I just asked it to make it more optimized. But yeah, could be problem in the prompt. Could be that it didn't see, but it should be able to understand. It could not see the first part. I just gave it the second part of the problem, but the first part was already solved inside, so it just should be able to understand from the context. It failed. Let's do the same thing, but yeah, what do we do? Let's remove. Let's ask it to do both parts. Let's remove the codes. We have only reading input, and let's see if it's able to solve both problems. I write full code of the module to solve both parts and make this as efficient as possible for faster calculations. Don't mind if we use more memory. Let's see again. Hello, hail enjoyment, and Dmitro Prokofiev. Okay, below is the Python module solution for both parts. Key ideas, memorization. It's going to use memorization. Since the browser problem statement doesn't show the full input, we are writing a general solution based on a given topic logic. The input would contain lines similar to those in the example. Okay. Yeah, it should work. Let's see. Again. I have only 5 responses until December 12th. Perfect. I'll need to then use the API playground. Okay, first result is the same and is fast, and was fast to receive, and the second part is not correct again. Interestingly, it's it's giving us the same result as in previous version that O1 was giving us. It is definitely faster than it was before, but the same. It's wrong. The answer is this, the correct answer, and is not this one. I don't know. Just hail enjoyment. I said hello. Yeah. I don't know. For some reason, O1 is just sucks. Sorry, OpenAI. Yeah. Why did it do that? I won't be trying one more response from it. Yeah. Okay, so again, Claude 3.5 Sonnet is the winner. Claude writes better code, more readable, more correct, more from the fewer shots. It didn't forget the import. What else? We've seen on the previous days that O1 failed multiple times, and then Claude just gives us the correct code in just one attempt, in one shot. So yeah, that's why I use Claude every day instead of O1, and I use O1 only for like really complex problems when Claude 3.5 Sonnet is not able to solve them. So I usually start from the Claude model, and then I switch to the O1, and I'll just compare the results. Yeah, I know, this is a nice red guitar. I'm waiting until you come and get it. It's in. It's really safe here. What was the correct response from Claude? Was it that? No. Merged. Not this one. Yeah, I'm not. I just forgot to commit the second part, the correct solution. Let's see if that's a correct one. By the way, it's in 10 minutes. I suppose OpenAI will start their next day of OpenAI, of 12 OpenAI days, and let's see what they show us today. It could be Sora. I could even stay. I could just even leave the streaming, and we'll see what they present us. What do you think about that? Do you like to watch the stream with me? I'll probably do that. Let's see. Yeah, I'm not sure if that's correct solution will be. I'll run it again on a Claude 3.5 Sonnet. Part 2. Yeah, it's not correct. By the way, what was this model? Evaluate expression. Wasn't it was probably correct one. Optimize solution. Did it work? Reply. Accept, and let's run it. Handle potential overflow. Yeah, it was probably a correct solution, but it wasn't faster. Where's my YouTube? OpenAI live. Aren't they going to give us something today? Should have been in like 8 minutes. Yeah, the correct solution is there. Okay, this is the correct one, but let's separate the first part solution from the second, and let's give it full problem, as it currently tries to calculate using the same function for the both parts. So, OpenAI. I don't see any notifications, but I've saw Sam Altman said that they are going to present something today. Where is it? Sam. Yeah, it said 12 hours ago. I'm so excited for what we have to launch on day 3. Monday feels so far away. Okay, so it's not today. Then, thank you for watching. We're not going to see anything from OpenAI today. For some reason, they decided to move it on Monday. You have a stream on Twitch. It will be a great opportunity to get more viewer. No, I don't like Twitch. I don't want to move there. I have a YouTube channel here, and yeah, who knows if those streams on YouTube will give me something. Yeah, oh, correct. So I'm committing this to the GitHub repo. Yeah. Thank you for watching, and have a good day. Have a good night.